We continue with particle in a box. I did this drawing again because I wanted to explain something. This is my function, my eigenfunction right here. This is my eigenvalue. Remember the number that we got, n, right? That is called the principal quantum number. And it should go over here. Psi n of x equals to e of n psi of n of x. And in the time dependent, it should go psi n, capital psi n, equals e to the negative I e n t over h bar, because it depends on the principal quantum number. And those numbers can only be 1, 2, 3, 4, and so on. Now what I wanted to explain, remember how when I did the drawing in my third video, I believe so, I had a no node here, I had one node here, I had two nodes here, and I had three nodes over here. But now, when you square psi of x, instead of having this node like this, okay, instead of having that, you're gonna have, I'm gonna put it right in the middle. It's gonna be somewhere on here. It's gonna be something that is gonna go, in the middle, something that is gonna go like this, smooth. It's gonna go up, then it's gonna come down. I'm trying to do my best. And remember, where's the, I don't want to do to prove where the highest probability of finding the particle is. It's right here, right in the middle. Common sense, right? If you take the average, it'll be at L over 2. And here I had two nodes. I had a sign. But this negative part that goes down like here, okay, since I'm squaring everything, it's going to be in this form like this. It's going to go up, it's going to go down, then it's going to go up, and then it's going to go down like that. And my probability of finding the particle to the left or to the right is what? 1/2. Over here also 1/2. Now over here, my probability density, right? The probability density weight. That's why when you square, what you're looking for is for the probability density weight, right? Now you're going to have 1, 2, 3, and 4. It's going to, the probability of finding is going to be 25%. 1/4 to either side. 1/4, 1/4, and 1/4. Over here I had 3 knots. It went up, it went down, and then it went up. So now it's going to go like this. It's going to go smooth like this. I'm doing my best. This. It's going to go up again. This. It's going to go up like this. That is what happened when you square the eigenfunction. Now your probability of finding the particle, okay, the average, is going to be, you have 6 sides. It's going to be 1, 6, 1, 6, 1, 6, 1, 6, 1, 6, and 1, 6. Okay, I also wanted for you to know, see the first energy, okay? In reality, I don't need this because this will be the very first, which will be 1 square. I mean, it's like that. This is the lowest energy value. This will be 4 times. This will be 9 times. The energy increases as it goes up. And this is called the very first, called the non-zero stage. It is already at the lowest energy value. Okay? The electron is always going to have a minimal value, energy value, and it's just going to, as a jump, it's going to be increasing and increasing and increasing as it goes up. I just wanted to clear this. Remember, this is how you will write the Hamiltonian, like this, because n is the principal quantum number and it needs to be this. There, this, the time dependent. This is the time dependent, and the other one is the time independent Schrodinger equation. This right here is the time independent Schrodinger equation, and this is the time dependent Schrodinger equation. If you like this video, please hit like and subscribe. Thank you.